Good day, everyone. Today, we're going to discuss and talk about the reactive powder concrete and what is a reactive powder concrete. First, let's talk about the contents of my presentation today. First one, introduction. Second one, the composition of reactive powder concrete, or what we call the RPC. Properties of RPC, application of RPC, advantages and disadvantages of RPC, chemistry behind RPC, difference from the normal powdered concrete, and last, conclusion. First, the introduction. RPC was first introduced by P. Richard and M. Cherezi. Um, P. Richard is a French chemist slash engineer, while M. Cherezi is a civil engineer currently based in Canada. RPC was first introduced in the early 1990s by researchers at Bouygues Laboratory at France, and the world's first RPC structure is the Sherbrooke Bridge in Canada, was constructed in July 1997. RPC is not just a simple mixture of cement, water, and aggregates. Sooner or later, we were going to discuss what are chemical reaction while mixing the materials and what are the materials added to improve the strength, ductility, and hardness of the concrete. What is your reactive powder concrete? The ductility and its hardness. RPC is an ultra-high strength and high-quality cementitious composite with advanced mechanical and chemical properties. The strength and its hardness. There are concretes that leads the way to the achievement of maximum compressive strength of the order 120 to 150 MPa. This 120 and 150 MPa is the compressive strength of a certain stone, rock, or a concrete. Um, Concrete now we use today, which is the high performance concrete or the traditional concrete, um, only has 70 to 100 MPa, which is very low compared to the compressive strength of RPC or reactive powder concrete. Composition of RPC. In order to increase the compressive strength of a concrete even further, the only way is to remove the coarse aggregate. If we remember, the normal concrete that we are using today or the traditional concrete that we are using only has cement, sand, water, and coarse aggregates. But now in RPC or reactive powder concrete, um, they are using cement, sand, water, silica fume, superplasticizer, crushed quartz, and steel fibers. RPC is not just a simple mixture of cement, water, and aggregates. Quite often, it contains mineral components and chemical admixtures having very specific characteristics which imparts specific properties to the concrete. Continuation. This is also part of composition of RPC or reactive powder concrete. Um, this in this presentation, we can also see the correct amount or the ratios of um, chemical admixtures and mineral components present in RPC or reactive powder concrete. The objectives of developing reactive powder concrete or the RPC. Elimination of coarse aggregate for enhancement of its homogeneity. The elimination of coarse aggregate or what we call gravel. They will use other substitutes or other chemical admixtures and mineral components to substitute and makes the concrete more ductile and strong. Next, utilization of pozzolanic properties of silica fume. Silica fume is a byproduct of a silicon metal. Optimal usage of superplasticizer to reduce which and at the same time improves compaction. A superplasticizer is a copolymer ester or CAE and polynaphthalene sulfonate which is PNS and polymethamine sulfonate which is PMS, and it is all a synthetic polymer present in an RPC or reactive powder concrete. Next one, post-set treatment for enhancement of the microstructure. And last, addition of small-sized steel fibers to improve the ductility. In the normal concrete or in the high-performance concrete, there is still a porosity or presence of small holes that might lead to a high persistence in the concrete or the high presence of permeability in a certain type of concrete. In this table, this is the presentation of how the RPC or the reactive powder concrete, um, the its composition shows the compositions or the weight and the how it distributes the proper amount of um, chemical admixtures um, and mineral components based on their compaction strength. Components with function parameters. First, the components. Sand. Its function parameters is give strength to aggregate. Second, cement. Its job or function parameter is to bind all materials present in the RPC or in the reactive powder concrete mixture. Quartz powder. Maximum reactivity during heat treating. Fourth, silica fume. Filling the voids. The job of silica fume is to reduce the permeability of a concrete or the porosity present in the concrete. Steel fibers. It improves its ductility or it improves the strength of the concrete. Last one, superplasticizer, reduce water binding because of its synthetic polymer or copolymer present in its chemical components. Next one, we're going to talk about the properties of reactive powder concrete or the RPC. First, fresh concrete properties, compressive strength, flexural strength, water absorption and permeability, chloride impermeability, frost resistance. First one, we're going to talk about its compressive strength. The compressive strength of the RPC or the reactive powder concretes. It has a higher compressive strength than normal concrete. It is a factor linked with durability of material. Maximum compressive strength of RPC is approximately 200 MPa. Next one is flexural strength. Plain RPC processes with flexural strength than regular concrete. The regular concrete only has a flexural strength or compre compressive strength of 70 to 100 MPa, which is very low compared to its flexural and compressive strength. By introducing steel fibers, RPC can achieve high strength. The length and diameter of the fibers have considerable impact on the strength. Now, let's talk about the resistance to chloride iron and penetration of RPC or reactive powder concrete. Increases when heat curing is done in concrete. Heat curing is when they are using thermal heat to improve its ductile and strength of the concrete. Heat cured RPC show higher value than normal cured. Heat cured uses thermal heat while normal cured only using light amount of water to improve its strength while it's still in the moist period or moist space. Last, homogeneity. Homogeneity or its purity. Improve by eliminating all coarse aggregate. By eliminating all coarse aggregate and using light amount of sand while substituting other kinds of mineral components such as steel fibers, silica fume, and superplasticizer. They improve the ductility, strength, and hardness of the concrete. Dry components for use in RPC is less than 600 micrometer. Um, 600 micrometer, it implies the low permeability or non-permeability of RPC because of the presence of silica fume, which fills the void inside or in the concrete. Application of RPC. So in the introduction, I already showed you the picture of Sherbrooke Bridge in Canada. That's the Sherbrooke Pedestrian Bridge. Advantage of RPC. It has the potential to structurally compete with steel. Superior strength combined with higher shear capacity result in significant lead load reduction. RPC can be used to resist all but direct primary tensile stress, improve seismic performance by reducing inertial load with lighter member. Low and non-interconnected porosity diminishes mass transfer, making penetration of liquid gas and non-existent. First, the first advantage of RPC. It has the potential structurally compete with steel. Um, the usage of steel, it may be lightweight, but its strength and compressive strength and its flexural strength are not comparable in terms or to compete with RPC. It has a superior strength combined with higher shear capacity resulted in significant load reduction. It is the second light kind of material to build an infrastructure or a bridge. So it is very convenient and cost efficient if you are going to use reactive powder concrete instead of using steels, pro-stress concrete, and enforced concrete. RPC can be used to resist all but directly primary tensile stress. Without the usage of enforcement bars, it already comparable to the strength of unenforcement concrete because of the presence of steel fibers um, in the mixture or in the um, components. Low non-interconnected porosity diminishes mass transfer, making penetration of liquid, gas, and non-existent. Um, our traditional concrete or our normal concrete or what we call high performance concrete still has permeability in terms of gas and liquid, while the reactive powder concrete is a non-permeable kind of concrete.
The chemistry behind the RPC or reactive powder concrete is where the dissolved cement produces hydroxyl ions. The hydroxyl ions came from the cement that is combined with water, and that process called hydration process. Hydration process can also lead to precipitation reaction, where the precipitation reaction cement produces huge amount of silicon and calcium in a solution. Precipitation reaction also produces new solid product that coat current cement and other aggregates. In a mixture of a normal concrete powder, water, sand, cement, and gravel are all normal mixture or part of the components of a concrete. But in a RPC or reactive powder concrete, the components or the materials that is present in the reaction are silica fumes, superplasticizer, and steel fibers.
And for the last conclusion, therefore I conclude, compared between the high performance concrete and reactive powder concrete, the reactive powder concrete is comparatively gives more compressive strength, tensile strength than performance concrete by replacing silica fumes, steel fibers, and superplasticizer by eliminating the coarse aggregate or the gravel. And next, the reactive powder concrete is also cost efficient than post-stress concrete and enforced concrete. It shows the lightweight base concrete while still having its non-permeability to gas and liquid and high compressive and flexural strength than other concrete. That's all. That's all. Thank you.